Electronic and invisibility systems. We left the 20th century behind. In that century, the technology revolution was experienced in a great openness, but we have only just begun to reap the fruits of the scientific and technological developments of those years. Most of the 20th century studies consisted of physics studies, particularly the departments of physics related to electricity have gained great momentum, and as a result, intertwined technical concepts and subcategories have emerged. Isn't that what it is? Devices developed in relation to electricity do not have a very long history, but the 20th century, and especially the second half of this century, when dizzying work took place, shows us how much effort people have put in. The invention of the bulb and gramophone brought along huge composites. As a result of the continuity of these studies, the science of physics has gained a new technical dimension, and this is called electronics. Electronic technical science has taken part in many aspects of life and is divided into hundreds of subcategories. Even within itself, it is divided into many subsections such as industrial electronics, medical electronics, digital electronics. So much so that the science of the electronic technology, which is included in the science of physics, has been taught in universities as a separate science. So, what is electronics and what operating principles does it address? This question requires an address that is too broad to be answered by hundreds of books. We can call this a technical science based on the control of low currents and high currents in voltages in general. In other words, this can be called the control of the current values at a small value and the currents at a very large value. This is found in all electronic devices from television to computers. Current is given at certain values, at certain time intervals, at certain frequencies, depending on the place, and thus electronic operating systems are created. I would like to express this thing in simple terms. You can use headphones or listen to the radio through the speaker when you're listening to the radio. This is done by giving certain values to the current. In other words, different values are used in the headphones and different values are used in the speakers. The example of using current at certain time intervals will be electronic clocks. When you set an electronic clock, the clock will not ring until the time you set it. When the clock rings, the electronic component of the watch sends current to the bell section of the watch. The use of current at certain frequencies can be exemplified by the channels in TV. The channels in the televisions are broadcast with frequency broadcasts made at certain frequency values, and therefore the frequency of one channel does not interfere with the frequency of the other channel. There's been a scientific fuss for a few years. This fuss is called invisibility and its system. I had a thought that I came up with before this fuss appeared, and it was done with electronic systems, but it was only theoretical. This is what I want to share with you in this article. Why do people want to be invisible in the first place? Let's look for an answer to this question first. First of all, we can think that people can use invisibility to learn some information in national and international relations. In a battle, troops or spies can obtain the information of the other party without being seen and without encountering any difficulties. For this reason, invisibility systems are a set of systems that adorn the dreams of many nations. However, if these systems fall into the wrong hands, they can also be used for theft and fraud. Those of you who have read my earlier scientific and especially technical essays know that technology is like a sea, and we are just a drop of water in the sea. The invisibility system can also be built using a complex electronic system. First of all, let's consider a material which is a cube. We will cover this cube-shaped material with a very thin LCD screen. After covering each side of the cube with this LCD, we will place the light-sensitive systems used in the cameras on each face as a thin slide under this LCD screen. Thanks to this light-sensitive circuit we have placed, the image on the front of the cube will fall on the back side, and the image on the back side will fall on the front side. For example, there's a wall at the front of the cube, and there's a vase at the back of the cube. So with these electronic systems, the image of the wall at the front of the cube will appear at the back, and the image of the vase at the back will appear at the front. Thus, the person standing in front of the cube will see the vase, not the cube, and the person standing in the back will see the wall instead of the cube. The same system will apply to the size of the cube, and the people on the side will not be able to see the cube either. The whole of these systems is theoretically possible, but the shading factor disrupts the work, because no LCD screen can provide lighting at sunlight level. I leave this to the electronics engineers to solve this problem. See you in another article of mine.